in person. Greatly appreciate it. So I have a tremendous pleasure of introducing Dr. Larkin, who is a professor in the Department of Teaching and Learning at Montclair State, so not very far away in New Jersey. His main research concerns the preparation of science teachers for culturally diverse students and issues of equity and justice in teacher preparation. So he's worked as a high school physics and chemistry teacher for 10 years, most recently in Trenton, New Jersey, and also served as a Peace Corps volunteer teaching physics and math in Kenya and in Papua New Guinea. He received his PhD in teacher education in 2010 from the University of Wisconsin-Madison. He is PI on multiple grants, including a current Impressed Voice, which is a Track 4 research grant that examines the retention of novice science teachers, and a Noise Track 1, which is an undergraduate scholarship grant at Montclair State, with funding. Both of these are funded by the National Science Foundation. And his work on these and other projects focuses on increasing the number of teachers from marginalized communities in our schools, which is a really critically important endeavor. He is a highly productive scholar. His work has been disseminated in research journals, practitioner journals, policy reports, and other venues. And I want to highlight in particular two of his books. So in 2013, Deep Knowledge, Learning to Teach Science for Understanding and Equity, which is a Teachers College Press. And this book was the UK Times Higher Education Suggested Reading List for 2013, or no, I think it was 2014. But and his more recent book from 2020, which is Teaching Science in Diverse Classrooms, Real Science for Real Students, through Routledge. And I've done I actually don't remember when.
Long time ago. We've done each other's orbits for a very long time.
So I am super excited to hear the really amazing work that he's doing in Montclair with pre-service teachers.
I've met.
I'm going to turn it over to him.
Would you be able to polish the mat on it? You have to take it
That's
off.
someone on mute, not muted on Zoom.
I got it.
Oh, all right. And thank you very much. Go ahead.
Thanks for that lovely introduction. So the title, I was asked for a title of the talk, and when I was thinking about this, so all of that work that Ravit was talking about with the Noise NSF project, I'm using this as an opportunity to not talk about that for once, because I've been doing a lot with that. The book portfolio has kind of taken over my life, and I'm using this as an opportunity to kind of tap back into another part of my program of research that I've kept going as almost a little bit of a side hustle. And it's been very generative for me, and it's been the reason why I got into this work in the first place. This photo here of move that arrow there. I'm not. Oh, of Einstein in space. This is from one of the papers that I'm going to talk about today. The pseudonym is Victor, and Victor, his students, they got a camera, like a GoPro, and they got a weather balloon. They put Einstein on a ruler, and they launched. This is a high school physics class. They launched Einstein into space, the Einstein doll into space. And so this is just a screen capture from the video clip of them seeing the edge of the earth. And I love that, the fact that they did that. And I do want to start with just a note of gratitude to Rutgers. I was a freshman. Well, when I was figuring out that I didn't want to be an engineer, but I spent my freshman year here, and then I moved on to Trenton State as an undergrad. But I have a soft spot in my heart for this campus. But a note of gratitude for inviting me here today. But also as somebody who's worked, I was a public school teacher for 12 years in New Jersey. I was very involved with the teachers union, and I have been a strike captain. And I want to just say thank you to Rutgers, because we just settled our contract, with the other the other state public institutions. We just settled our contract pretty favorable terms, and I think part of that is because of the work and the sacrifices that you all made, both the faculty and staff and the teachers, the adjuncts, teaching assistant unions, all of that. So I just want to say thank you, because it's a lot of hard work. You guys went through some stuff earlier this year, and I just want to say thank you. So I'm going to give sort of a spoiler alert. I'm going to give just sort of the end of the talk first, just to tell you where I ended up. And I'm going to just sort of talk about the last maybe 7 years of work on this project of teacher conception. And the thing that sent me back to grad school after vowing never to set foot on a college campus again, the thing that sent me back was just like, why is teaching still like this, right? And how come these teachers don't last, right? Like, I was in a classroom and I had an algebra class next to me where they had just a complete turnover of subs for the full year. These kids did not have it now all year long. And then we would have teachers come in. Some of them had been recruited from overseas. Some of them were trying out teaching as a profession. We know that's something about teaching. But still, there was this issue of like, teachers didn't stay. And even when they did, sometimes the teaching didn't improve over time. Like, just sticking around didn't mean that you got better as a teacher. It did sometimes for some people, but not always. And so this problem of like the quality of teaching, particularly science teaching, and then particularly science teaching with students who were particularly marginalized from wider opportunities to learn science. That was the thing that sent me back. So the sort of end of the talk, where I'm going to end, is that the way I'm identifying the problem with science teaching now is that many science teachers still think their job is to provide information to students and then verify that that information has been successfully transmitted. I mean, fax machines do that, right? But I don't think we want teachers to do that. But that's still sort of a dominant paradigm in what science teaching is. And I work mostly with high school science teaching, right? So it can be different in elementary and middle grades, but this is sort of how I'm defining the problem. And then my explanation, right? This is really like a claim evidence reasoning thing. What I'm saying that why this is because, this is teachers' own conceptions of what science teaching is shaped by their own experiences in learning in school. So they're kind of reproducing what they've learned. And so it's almost a radical note. It sounds really simple, but it is really radical when you think about the implication. I'm increasingly convinced that a robust understanding of human learning, like how people learn, and then how to teach, is no less important than literacy and mathematics. And when I think I like to do like the Star Trek thing, where like what's science teaching gonna look like 200 years from now, if we can survive all this stuff we got going on? Like what's it gonna look like? And I think that learning how to teach and learning how to learn is going to be as fundamental as literacy and math. I don't have a fancy name for it, like literacy or anything like that, but I think that's what that's going to be part of what it means to be an educated citizen in a democracy. And just to put it really bluntly in the terms that I'm going to talk about today, in terms of conceptions of science teaching, I would say an appropriate conception of science teaching views successful learning as that which makes it possible for the learner to subsequently teach what they have learned to others. That is my new definition of what it means to successfully learn something. And this has its place already in the classroom, where we pair up with a partner and have the one student who knows it already teach it to somebody who doesn't. But we're not saying anything about how that teaching and learning is supposed to happen. Yet some of the peer interactions that they normally engage in occur, and that helps with the learning. But to me, this is like part and parcel of what it means to learn something. And you can successfully teach it to others, and you have some strategies for how to teach it. So I'm going to show you how I got here through. I'm going to go through like 4 papers that have been published over the past couple of years. But I want to ground this in the work of 3 people in particular. One, this may be a familiar name, maybe not. Peter Hewson. He was one of the professors that I first encountered when my wife went back to grad school. And I was like, well, I'll come with you, like, to help find the building, but I'm not going back to grad school. And I met Peter there, and he said, oh, there's a group of physics teachers meeting. If you want to meet with them, I was like, yeah, I'll talk to other physics teachers. I don't want to be here in this building, but I'll go talk to other physics teachers. But anyway, Peter became a close friend and colleague. And so some of you may know this paper, A Combination of a Science a scientific conception towards a theory of conceptual change. This is a paper that was literally a paradigm shift in the field of educational psychology. Peter was a physicist. He was working on particle physics, and this was a paper that came out of his graduate experience of trying to teach relativity to students. Like, well, how do they change their ideas about relativity? This has become one of the most cited papers in all of science education. If you haven't read it, when you read it, you'll be like, oh, well, this seems normal. Like, this seems normal. It was not normal. It was groundbreaking at the time. They were covering new ground, and there's been so many papers that cite this. And I have put a copy of it. So every paper that I'm going to mention today, I have a folder, I have a QR code. You can scan the folder. I'll share it with Aaron and everybody. Everything I'm going to talk about, I'm just going to give you a copy of it. So this paper's in there. The second part. Oh, one other thing about Peter is that he started out as a physicist, working on this particle physics. And he ended up when he retired from UW-Madison, he was known as one of the sort of leading people in understanding professional development for science teachers. And part of me, like when I look, I'm like, how does that happen? Like, I get it. I totally get how that happens. Because I'm sort of on a similar journey myself, looking at teacher retention after coming in, as a physicist also. The second person who I want to mention that this work builds on is Julie Luck. Julie started out at the University of Arizona. She's an endowed professor at University of Georgia now. But she had this paper, and this was the paper that made me realize, like, oh, I can do this. This can be stuff that you study. She was looking at a single case of a teacher, and she was supervising science student teachers, of a teacher who wanted to learn to teach science, but apply some of these ideas from this multicultural class that she had to science. And I was like, yes, that's what I want to do. And again, over time, these people become people that you know and that you work with. So I didn't meet Julie until much later. I met her I think I realized I was sitting next to her at an ABA or something. And of course, she ended up talking to me for a long time, and it was really helpful. And the third person I want to talk about is Gloria Billings. And this paper in particular, so Gloria was my advisor at the University of Wisconsin. One of the things she's known for is critical race theory, not the boogeyman critical race theory that's out there, but like the actual scholarly critical race theory that has explanatory power in terms of understanding structural racism in particular. So she's written about critical race theory a lot. And one of the tenets of critical race theory is a critique of liberalism, and a particular part of liberalism. And that's like that idea that we progress, like society progresses in these slow incremental changes. And we just have to wait for each change, wait. And so critical race theory comes back and says that may not be an actually a good model of how change actually occurs. And so the four papers I'm going to show draw from all three of those scholars, among many other people, but that's sort of the conceptual ground. That was my starting point for this work. The driving questions in this program of research, again, going back to that question I had as a classroom teacher, like how do conceptions of teaching science influence how science teachers teach? I'm going to give a couple examples of that in a minute. But like any grad student, you come in with this big question and you're like, oh, people have already researched this. And this was actually well-covered ground when I started my own study. But the thing that hadn't been looked at much is, well, how does that stuff change over time? And what are the causes and determinants of that change over time? That was something that really hadn't been studied much. And that first book that Ravi mentioned, that answers or addresses, not fully answers, but that addresses that question. And then the last bullet point was how do these conceptions of teaching science and the work of science teacher education connect to this larger work of fostering equity and justice in science education? And to me, that's part of the conception piece, because for some science teachers, they don't consider equity and justice to be part of what they're doing. There's this really nice quote by James Banks, where somebody asks him, well, how can an atom be multicultural? Right? And he says it's an atom that everybody can understand. Right? So this idea that the subject matter doesn't exist in isolation. And we can get philosophy of science. We can get to the philosophy of science real quick by epistemological route saying, where does all knowledge exist? It's all, all of science is in our heads, our collective heads, right? Like if we disappear tomorrow, science does too. Planets keep moving in orbits and stuff, but like our collective scientific knowledge is part of that. And so the argument that I'm making here is that these notions of equity and justice are part and parcel, or should be part and parcel of a conception of teaching. And I just want to just lay this out, like from a constructivist standpoint, and this is a different way of saying what that paper by Posner, Strike, and Hewson and Gerzog in 1982 said. The student ideas are the raw material of our work as teachers. We can't just deliver things to students. We have to be working with their ideas, but even the metaphor falls short because we're not the ones working the clay. The students are the ones working the clay on their ideas. And so that's, I just sort of want to enter at that point. I'm going to be real quick about this. This may be familiar ground for folks, but I'll show you where it can. So I just want to talk a little bit about theories of teacher knowledge and teacher learning. And probably the place to start is with Lee Shulman's, Knowledge and Teaching Foundations of the New Reform paper that came out in the early 80s, which signaled this shift away from what was process product. If we do this, then this happens, right? That was the way that teacher education research really took place in the early 80s and before. And with Shulman, it had this shift to the cognitive. We have to really look at how teachers are thinking about things. And then so after Shulman, we had this sort of Cambrian explosion of models of teacher knowledge, where we have all these diagrams, all these people sort of sorting and categorizing all the different types of teacher knowledge. And some of this is very useful. But I think it's always a good question to ask, like, well, what do these models do for you? What explanatory power do they have? And in particular, I want to just, PCK, I made this little PCK jar thing because there's a group of colleagues that I work with that if anybody says PCK, they have to put $1 in the jar. And PCK stands for pedagogical content knowledge. It was one of Lee Shulman's constructs out of that paper. This comes from short comment. PCK is one of those things. It's like, I think of it as looking where the light is when you do something, right? Like it's there. You can build instruments out of it. You can write papers out of it. You can publish. People have gotten tenure off of PCK, but for me, it always falls a little bit short in that explanatory power. What does PCK explain that other things do? Right? And so this is part of those models of teacher knowledge. And the other thing that PCK tends to be one of those things people try to transfer, right, to deliver from one person to another. And sometimes that works, and sometimes you need to know how to operate a current balance if you're going to teach an advanced physics class. But what do we gain by calling that PCK? And so the place I want to land with these models of teacher knowledge is there was this other model that was sort of out there that came together at NARST, and this is way before my time, but like in the late 80s, there was a group at NARST that said, hey, there's all this attention to science teaching now. We don't have a good definition of what science teaching is. So there's actually a NARST panel that came together, NARST, National Association of Research in Science Teaching. That's what it stood for at the time. Now it has a much longer acronym. It's a very long name. But the idea is that this working group came up with these 6 things that they said, this is what teaching science is. It includes learning, it includes the nature of science, it includes learner characteristics, it includes preferred instructional techniques, and a rationale for why we're doing what we're doing. And there's this larger umbrella, conceptions of teaching science, that all of these fit. And all of these were relational. And this was what the working group put out, as this is what we should call an appropriate conception of teaching science. In fact, that's the name of the paper. And again, that's in the folder that I'll share later. Okay. Then we just have to kind of acknowledge that that's still all a very cognitive view. And if we fast forward to 2023, the cognitive view stuff is still there and very helpful. But in teacher ed now, like we work a lot with the sociocultural models of teacher knowledge. So starting with Levin and Wenger, up through the core practice movement, like the knowledge exists in socially mediated practices between between individuals, between expert and novice. And then, this idea of ambitious and equitable instruction. This book by Alana Horn and Brett Garner is like my favorite book from the last 2 years. And it's a wonderful, wonderful book. I don't nominate books for awards very often, but I nominated this one. It didn't really, but so we have these sociocultural models that are out there also. So the big ideas from this little detour, one, like categorizing knowledge is useful when we're looking at how that knowledge changes over time. That's why I find it sometimes useful to use those categories of knowledge, but really it's about like trying to measure a delta Y, right? This person used to be here about that idea and now they're here. So I can, and I can only do that if I can create a construct where I'm saying I'm talking about this piece of knowledge. And the other thing is that, and this might be obvious, but I feel it needs to be said, is that the cognitive models, and in this case, I'm talking about conceptual change, and sociocultural models of teacher knowledge, they do inform one another. Cognitive models tend to be more individualistic. Sociocultural models are obviously, groups of people and communication between those people, but neither one has sort of sole domain on informing this particular program of research. And the last thing, just to come back to this diagram, the other piece, which interestingly enough, this idea of a conceptual ecology goes back to Stephen Toulmin in the 1950s. And some of you may be familiar with Toulmin's model of argumentation, right? Which if you're teaching science, claim, evidence, freedom, in fact, that comes directly from Toulmin. And so Houston and Houston took these, and this is Peter Houston and his wife Mariana, who worked together on a bunch of these papers in the late 80s and early 90s. They took this appropriate conception of teaching science and tried to look at how these things hung together for a particular individual. And they use this notion of a conceptual ecology. And it's not that different from Joe Novak's, the concept mapping, right? Where ideas are connected and, in maybe a very simplified way, it's sort of a map of a brain, right? In the way, however neurons work to store ideas, which is an open area of research if anybody's interested. But like these ideas are connected in some ways. And then later on, so in my work with Tanya Maloney and Gail Perry Ryder, much later on, we found that this notion of changes in a conceptual ecology was really limited by those connections, by these, and we thought of them as ropes, right? And if a rope is really tight, if it's not loose at all, and there's no room to wiggle that conception at all, that in fact, that affects how this other conception is going to move. And we saw that particularly with race. If people had fixed ideas about race, ethnicity, language, ability, whatever dimension of diversity one cares to look at, that sort of fixed point. And again, we thought of it as a short rope. And the metaphor I had was, I think I had people working on trees in our street that week. And I was watching them like, they had this rope tight and this rope tight. And if all the ropes were tight, they weren't going to go anywhere. So they had to put a little slack in one rope if they were going to move, right? So that was sort of the three-dimensional metaphor that I had in my head for this conceptual ecology. But it seems to hold. If one of those ropes is short and it doesn't allow for movement, that is going to constrain what other movement is possible. Okay, so we still have this metaphor of delivering information from one person's brain to another. David Stroop has this really nice phrase, delivery pedagogy, right? Instruction in which an individual teacher delivers subject matter information to students through various fact-laden presentations. This is still our dominant model of high school science teaching. Even given sort of the shifts that AP has had over the last few, last decade or so. And I want to say, so this is, Ravit mentioned that I was a teacher in Kenya. So this is a picture of our science, what do we call it? I think they called it Science Olympics. It wasn't Science Olympia. They called it Science Olympics then. And so this is Ms. Simiyu, who was the chemistry teacher. I was the physics teacher. And this is our team that went to compete at another high school. In Kenya, there were only a couple sources of information for our students. There was whatever the textbook said, and there was whatever I said or wrote on the board in class. That was it. That was their only way or whatever they talked to from other students, or, you know, they would get past exams or whatever. But there was a big exam at the end of that for their 4 years of high school. And everything that they were tested on came from limited sources. It came from a textbook or a teacher. And so in this case, like they depended on delivery pedagogy, because if I didn't deliver them the information on, you know, Newton's second law, they weren't going to get it from those things. That's very different from today, when if somebody wants to learn something, there are so many ways for them to do it, right? And I use this example because I have a car kid, and there's always a car open in our driveway, right? Like, and so when he wants to learn how to repair something, first thing he does is hop onto YouTube and see how somebody else does it. And so, and we can, that's exponential for our students today. There's so many different ways for them to learn things. We're not just the sole source of information. And so that delivery pedagogy doesn't make sense in our current context, right? I mean, if we lose the internet forever for some reason, it might make a comeback, right? But like, even because we can access information from so many different sources, depending on the teacher to deliver it to a student doesn't make as much sense. Now, what a teacher can do, and good teachers do, is they help students organize that information they do have, you know, according to those principles of learning. Like if we go back to the how students learn, how people learn framework, you know, organizing information for retrieval, that is something that teachers can really help students do. But just delivering that information in the first place, we don't need it as much. Okay. How am I doing on time? All right, I'm gonna, my goal is to take maybe 10 more minutes of this, and then I want to open it up for a conversation. Okay, so this first paper, it was an invited response because I had opinions. And this was this paper that had reckoned with this notion of hands-on in science, and particularly the term hands-on and what that signified. And, you know, to some, that phrase hands-on is really important because it's contrast with that delivery pedagogy. But for other people, hands-on, we know that just because you're touching stuff doesn't mean you're actually learning, right? So there's like a split in the field about whether we should even use that. And so part of my point was, well, this all depends on what the public understanding of science ed is. If the public understanding of science ed is rooted in delivery pedagogy, of course hands-on is better, right? Like, who's going to argue with that? But maybe we can work on this notion of what a public understanding of science ed is. Like, we should have a robust vision of pedagogy in that public understanding of science ed. And NGSS gets us close, but there's not much pedagogy and like how we should teach this stuff. And that's been really the project of the last, you know, since the standards were out, and probably the next 10 years, like figure out, okay, we have this rich, robust vision of three-dimensional NGSS science learning. How do we actually teach that? A lot of the focus has been on assessments, and I think that's a good thing. But I think working on the sort of public, when people hear science teaching, they automatically still think delivery pedagogy in that dry, boring class where somebody is talking at them. And then it's this, the other point I made in this paper is the, you know, terminology. And I think science teachers kind of get hung up on terminology sometimes. And it can be dogmatic, right? So I remember one particular science professor who got very upset if somebody used the term mass to mean weight or weight to mean mass. Or I've heard it recently, like saying global warming instead of climate change, right? And I think from a constructivist point of view, we have to recognize that these are just labels on folders, right? These are just markers of conception. I've heard it with the term gravity too. Like some science teachers don't want students to use the word gravity at all. And I can see where that's coming from, but I also think it can get dogmatic, where we're too worried about delivering the correct message. Then, okay, well, that word is a marker for some students' ideas. Can we get to the idea and worry a little less about the marker, or come back around to the marker? The whole notion of pre-teaching vocab has been empirically, to Brian Brown's work is fantastic on it, but like, it doesn't work as well, right? What's better is developing that student's notion of the concept and then giving them the science word label that they can attach to it later. And last is that, you know, rational consideration of evidence is sometimes insufficient to change people's minds. And so I think in science ed, we've been somewhat empirical and trying to be coldly rational about trying to change people's minds. But one of the critiques of that paper, that conceptual change paper from 1982, was that it did not attend to emotion and the role emotion plays in cognition. And so one of the things we know now that wasn't as well understood in the early 80s was that we do have to bring emotion into our science lessons. And that, so in terms of talking about conceptions of teaching science, that has to be part of our conception of science teaching as well. Okay. So Houston, I mentioned their work. They had this protocol, and they had it for different subject areas. But basically, they would ask respondents, this is a qualitative interview protocol. They would give out these scenarios and say, is there science teaching happening here? If not, what would you need to know in order to decide if you can't decide? So a teacher handing around crystals before teaching it. What can you tell me about the crystals I've passed around the class? Is that science teaching? Is a student at home watching a TV program science teaching? Right? And there's a whole bunch of these prompts. And when you put them together and you analyze them through that appropriate conception of science teaching framework, you can come up with a pretty good picture of what that person's conception of science teaching is based on that framework. And so my doctoral student, Liz Carletta, and I think this is in Toronto at an AERA, maybe 2017 or 2018, maybe. But we had 10 students over a period of a year throughout their program and looked at how their conceptions changed over time. Then fast forward a little bit, we took one of these, and we wanted to do more, but the three that we had identified, only one of those students was still teaching. Two of them had left teaching. That's more my retention bucket that I'm not talking about. But we looked at that, okay, over a 10-year period, how does this person's conceptions about science teaching change over time? And so we made a longitudinal case study out of it. And we confirmed some things that we know from our field already. Teachers who try to change an aspect of their practice can be successful, especially when they accept a need to rethink their existing ideas. So Victor was the one who did the physics, the Einstein in space. He knew that he had to change his ideas on assessment. He was very dissatisfied with his prior ideas about assessment and grading. And he made that a project kind of in the middle part of it, like his years 4 to 6 in his teaching. He really worked on assessment, and his ideas changed completely, as I'll show in a minute. But then we also saw that experience was no guarantee for conceptual change for teacher knowledge, even if confidence and comfort increased. So, and again, there was Hewson and Ken Zeichner did a study in 1999 where they looked at teacher knowledge, subject matter knowledge, among other things. And one of the things they found in that was that even if people felt more comfortable about teaching biology, Mendelian genetics over time, they didn't actually, when they took an objective test on what they knew about Mendelian genetics, it hadn't changed over, that longitudinal period, but they felt more comfortable and confident in teaching a subject that their actual knowledge about it hadn't increased. And we saw that in this case as well. And we also saw that teacher conceptual change with regard to issues of student diversity, at least in Victor's case, was highly dependent on the teacher's identity, personal history, teaching context, and experiences. So I'm going to talk about this in just a moment here. So I mentioned the assessment. There were a lot of changes in Victor's conceptions about what learning was. And this was driven mostly by his focus on assessment. He put a lot of slack in that rope. And then he had a lot of room to move and change in talking about learning. So what stayed the same is he said learning requires active participation, but his initial view of learning was what gets remembered afterwards. And later he shifted that to understanding learning as application, right? And this was part of that assessment. Like he didn't think that just being able to say something back was actually learning. And the thing that kind of blew his mind over time was like, oh, I can shape this. I mean, again, it seems sort of common sense, but he recognized that, oh, I can influence the direction of that learning based on what I do in my classroom. And it wasn't just sort of this, a student is going to grow. He's like, oh, I can have the student grow in this direction if we focus on this classroom. When we compare that to his conceptions about diversity, For him, he focused mostly on race and gender, and he was in a school that was predominantly white. And there was little evidence that he was able to reflect on his own race or the race of others in a systematic or holistic way. And we saw this as a short rope. This was a place where he didn't have much give and couldn't change. That was in comparison to gender, where his classes were about half identified as male, half identified female. But so he had issues of gender in front of him all the time. He didn't have issues of race in front of him all the time. And so with gender issues, he was able to loosen that rope a little bit and change some of his ideas about participation and grouping and some of those other things that didn't necessarily happen with his conceptions about diversity and the pedagogical implications of diversity. Okay, so that leads me to the next paper with my co-authors, Tanya Maloney, who is at Montclair with me, and Nishrak Hoke, who's at Penn State now. So the conception of teaching science that was presented to science teacher candidates in 3 different programs. We looked at teacher ed programs. And all 3 programs left the candidates unprepared to address racism both within and beyond their classrooms. And we saw this as, again, I'm framing this as part of the teacher conception, like, well, what's your job when you're doing science, right? And we saw 3 sort of areas where if teacher ed programs did more of this, it would make it more likely that teachers would be better prepared to address racism in their class. One would be to situate race and justice in relation to the task of teaching. Again, science isn't necessarily this neutral subject. It's embedded in people's lives in different ways, and different people have different access to the opportunities to learn science. And there was also, if there was more opportunity to learn about the schools and communities as socio-historical and cultural settings, rather than as places where you deliver the information, right? So make some space for not just what the students are bringing, but how that environment shapes that learning. And then, so there was one person in this case study who had been a chicken activist. Or farm activist, sorry. She had helped to shepherd through a backyard chicken ordinance in her town. She was actually a raw milk advocate, which is still really controversial. That was in Wisconsin. And yet she had this really activist identity that was not activated at all in her language. And so we argue, like, if somebody's coming in and they know how to, they have a sort of a mindset to do that, why are we tamping that down? And again, so what's part of that conception of teaching science? If you conceive of science teaching as the efficient delivery of information, of course, being an activist doesn't matter to that. But if you consider teaching science as figuring out what your students know and how they're going to learn and how you can teach them, then there's a role for that. And the last piece I want to mention is a recent essay. Again, this was an invited piece for Science Ed and Ravit. I believe you might have been part of this project as well. But this is a rethinking of that appropriate conception of teaching science from 1989. Okay, let's look at it from in 2022, and let's see what this looks like. So we start with those 6 pieces of a conception of teaching science that are still very much active in play. And from NGSS, we know that we have to incorporate knowledge of the nature and the practices of science, that's part of the conception of teaching science. That is a result of all the things that happened in the 80s and 90s and early 2000s around and the National Science Ed Standards, the Science for All Americans, all that stuff led to us as a community saying, hey, we really need to include the practices of science as part of science teaching. And then bring in that Schulman piece where he also, one of his things that gets overlooked a lot, but that understanding of sociocultural context, which again showed up in some of these other papers. So those are kind of already in the public, at least in the science ed mind of it. And then the 3 things that I'm adding to this conception. One is that student access to the subject matter. So this can be from an inclusion standpoint or universal design for learning, like thinking about how our students are going to have access to what we want them to do. And those resources can be access to upper level science classes, right? There are still schools in New Jersey that only offer biology and chemistry in high school. because that's all they can teach, and they do like some other environmental science, right? So those students don't have the same opportunity as somebody in another school where they've got 5 different APs and all these upper level electives, and students take 6 science courses over their 4 years of high school. But student access to the subject matter is part of that conception of teaching science. I didn't get in trouble for this, but it kind of felt like something as a new teacher, it felt a little risky. But I went down to the guidance office when I was a teacher I was in Hamilton Township at the time. And I was like, why are all the Black kids in my C-level science class? My A-level science class is all white. Like, how does that happen? Like, that's a structural issue. And so that was an access to it, because the teaching and there's a whole thing about like tracked classes anyway, right? But like, we need to attend to that. That's part of the conception of science teaching that I'm proposing here. And there's also that systemic barrier awareness and mitigation. Okay, so students do have these barriers to their learning science. How do we, being a science teacher, and our conception of science teaching ought to be overcoming them. So going out and observing the moon every night for a month is a common middle school activity, the phases of the moon kind of thing. But I was in a classroom where I heard one student say to another, my mom doesn't let me go out after 6 o'clock, right? And it was a safety issue for the mom. Well, the moon's going to be up after 6 o'clock, right? So and does the teacher know that, right? And that's just a tiny example, but there's all these other systemic barriers that pop up with relation to science teaching that I argue that science teachers need to be aware of. And the last piece is that embedding understanding of science teaching and learning, that, what it means to fully understand Newton's second law of motion is that different ways to teach it to different people. Like that's what it means to know it. And in the argument I make in the paper is it's a nonlinear process, right? It's a recursive process because the output becomes the new input, right? So if we know in the United States, there's about 330 million people, there's about 3.3 million teachers, so about 1% of the U.S. population is an educator, right? So if those teachers are, if 1% of the student population then becomes teachers, they're the next generation of teachers, right? They have a really strong, shaping over what the next generation of students thinks that science teaching and learning is, and so this is a recursive process. And so my argument is we have to pay attention to this, because if we don't, by the time we're in a teacher prep program, it might be too late to talk about, what does it mean to teach and learn. Hopefully they have some other base to think about that. And so I'm going to close with this question. What would happen to conceptions of teaching and learning if knowledge about how to teach and learn was as central to school curriculum as literacy, mathematics, and science? Like if teaching and learning is a school subject, and maybe that's an impoverished way of thinking about, school 200 years from now, but like if we said, an educated person needs to understand learning and teaching, how might that change what teaching and learning looks like in science classrooms? And so I'm ending where I started, that appropriate conception views science successful learning as that which makes it possible for learners to subsequently teach what they have learned to others. So I think I'm going to stop there, and I'll leave this QR code up there to a Google folder. Every article I mentioned and a copy of these slides are in there. If you like.
I'm going to take a look at the chat, and if you have questions on the folks on Zoom, please put them in the chat. I'm going to start with people in the room. If anyone has a question, and then we'll move on to questions on the Zoom. Anybody have a question here? If not, I do. I always have a question. Go ahead, Mary.
Thank you. You can say your name and where and your role.
Yeah, I'm Mary Kern. I'm here in language education. I love this idea of, the having learning and teaching as, something we learn to help us learn. Can you give an example of what that looks like in a middle school class or a high school classroom? Like when you have observed it or how it's happened?
So part of this is me trying to will it into existence. I can say that what I would be my dream is that, okay, we're pairing students up together. Let's say we're having them work on, I'm out of my depth with the language and literacy stuff. So let me go to like a math example. Like, okay, we give them the staircase problem, right? If you increase the number of blocks, how many blocks will be in the staircase total? Come up with a couple of ways to solve that problem, or talk about how you solve that problem. Once they figure it out, I think there's a, and this fits really nicely with the metacognitive piece in the How Students Learn framework, where they have to talk about their own like progression. Like, here's how I learned that idea. And I think and I probably pull on math unfairly because they've worked on this like a lot, right? Like, there's multiple pathways to a solution. Talk through your ideas. The idea that there can be multiple ways to solve a particular problem lends itself nicely to the idea there are multiple ways to learn how to do a particular problem. So in a middle school classroom, you would have students articulating their ideas about, or articulating their own, here's how I figured out how to do this. And then, if we mix it up a little bit and they're paired with somebody else, they have to both teach their way to that person, and they have to learn the way the other person solved the problem. And then synthesize that. Let's go a little higher up on the Bloom's taxonomy. So what does that say about teaching and learning? What did you notice? So instead of saying, what did you notice about the math problem, right? That, okay, it's an x squared plus n kind of problem. Like, what did you notice about your own teaching and learning? So kind of turn the lens back onto the teaching and learning. And obviously, if we're going to do that, we need to make space for it, right? Which means shedding some things from our curriculum. But I would say that's kind of a different problem, that we've got too many things in there because we're trying to deliver them all. Does that get at your question?
Thank you.
So I'm noticing Liz has a question on the chat. Liz, do you want to just unmute and say it?
Yeah, sure. I work with science teachers a lot, and one topic I have with them is this idea of sense making and how they can actually get out of the way and let the students do a lot of the sense making on their own. So since you work with pre-service teachers as well, what are some strategies that you give them to encourage them to help the students actually engage in sense making in a meaningful way?
So I don't want this to come across as glib or overly simplistic, but sometimes teachers just need to stop talking. Right? And create, I think there's this thing where it's like stop, if they stop talking, it's like the coyote notices they're over the cliff and they feel like they're going to fall if they just create space and moments in the classroom and to be filled with student talk, right? So I think part of the issue there is that many, especially pre-service teachers, they're hanging on to those ropes really tightly. And so they feel like if they're not in control every moment of the classroom, that terrible things are going to happen, which, to be fair, terrible things do happen when teachers are not in control of their classrooms. But that's not what we're talking about here. We're talking about the ideas, right? So if a teacher can present something to students and give students time and space to discuss and talk about it, and then, just to take a leaf from the ambitious science teaching folks, to make that talk a centerpiece of the classroom. Because the other thing the sociocultural view of teaching tells us is that talking is learning, right? And our brain works funny sometimes. It's like we have to say it, have it go out of our mouths and back in our ears for us to understand, for us to know something a different way. And I'm sure I could make up something that sounds good about cognitive processing with that. But that's what happens when students have somebody else to say it to. And there's the audience piece too. Like, oh, I need to shape this so that you get what I'm talking about. And that's another piece of that learning. Like we don't always make that explicit. So yeah, so we tell our teachers to stop talking so much and to give students time to talk, and that not everything needs to be mediated through the teacher. That some of those conversations can be student to student. And the more that we can do that and structure there's ways to structure accountability into those conversations. I like whiteboards a lot, like those portable whiteboards are great for that kind of stuff, to even just document what did we talk about. And that can be a way for, a teacher just to kind of walk around the room and listen to the conversations and say, oh, that's good. Can you write that down on your board? That's all the teacher has to say. What pre-service teachers tend to do is like, oh, okay, so you understood that. Now what should you do? Now what should you do? And they pepper them with questions. And students are just like under the desk. I don't know, Liz, does that answer your question? I feel like I took a short question, took a long one.
That was great. Thank you.
Questions?
I have a question.
Go ahead.
Hi, or unless someone else had a question on that. I'm a doctoral candidate here. I work with Ludwig. And I'm wondering if you have any insights about how teachers come to realize or accept that they need to rethink a particular aspect of their teaching or continue to rethink it, especially given that, as you said, growing confidence and comfort can come without conceptual change.
Right. So really the answer, like, how do you create dissatisfaction with a conception? Right? And with the idea that if they're dissatisfied with the conception enough, they'll look for an alternative. A good example of that is homework, right? Like a lot of teachers know that they have to give homework. They feel like they're not doing their job if they don't give students homework, but they're dissatisfied with it. But they're not going to change their behavior because of the context that they're in. Right? They're like, well, I have to give homework. Well, so you can create dissatisfaction with that, but that doesn't mean the teacher is going to change what they do, even if they change their idea, right? So changing what you think versus changing what you do can be two totally different things, right? As we've learned during COVID, right? Like sometimes people know what the right thing is to do, but like, I'm not going to put on a mask because nobody else does, right? Like it's that same kind of thinking. So I'll give you my answer to it. We haven't figured this out as a field yet, but my answer to it is kind of the same answer I just told Liz. Is like, let's talk about it. Like, why is it hard? Like, okay, here's what you think about homework. What are you trying to achieve by homework? What's the goal? Well, I want students to practice the problems until they can get it without fail. Okay. Is there another way to do that? Is there another way to make sure that they understand the material, if that's what you're trying to do? And so sometimes it's just having those ideas. And I think the best teachers do a version of that YouTube thing, or, like, I'm sure half of us have 50 browser tabs open right now. We do that. It's that lateral thinking stuff, right? Like I'm just going to keep this open because I might come back to it. Just keep until, and so I think, again, part of that is the intensification of teaching, where like there's so many things going on, you just don't want to mess with it because of what the consequences are going to be. But like in the case of Victor, when he was just so frustrated with grading because his students were getting A's, but on the conceptual questions, they weren't understanding the physics at all. So he recognized like this is a false measure. And that bothered him more than anything else. Like it wasn't the grading, like the actual sitting down, having to grade papers on the weekend. That was bothersome. But what really motivated him to like change it was like, this is not an accurate measure. And I like accurate measures. And it's not. And that's a problem. Like I don't want to be a fraud. And so that's where it comes into identity as well. And so dissatisfaction isn't just realizing that, okay, this thing that I'm doing is wrong. It's much more, and that connects to the emotion piece, right? It's much more personal than that. Like, I want to be doing something that's both ineffective and fraudulent. That doesn't feel good. That's not why I got into teaching. That answers your question. But
It's a difficult question to answer. I think it does answer the question.
It is, but I think there's sort of a counter. There's a thing that, and God bless administrators, especially 2023. But there's a thing that people who are well-intentioned, some of them administrators, some of them teacher developers, try to do, where they try to point out why somebody's approach is wrong, and that backfires a lot because it doesn't take into account like the person knows like, okay, this isn't a great way to do it, but I don't like any of your other options. And so sometimes that peer-to-peer stuff I think the most effective professional development we could do that's low cost is just to get into each other's classrooms and talk about what we see there in a low threat way. Right? Japan's kind of figured this out and they built it into their whole system of lesson study. We had an issue with one of our, I'm not going to out the person, but we had an issue with somebody who didn't like the fact that somebody else was even coming in their classroom. right? There's that protected nature, and we can point to evaluation systems and other things that make having somebody in your room become a high threat environment rather than a collaborative one. But I think if we can have discussions about our teaching, right? Like, I love Mr. Rogers. Like, I am a Mr. Rogers stan, I've been told. Like, I really like, and the thing that Mr. Rogers does, and if I might be dating myself here with the public television reference, but the thing that Mr. Rogers does, okay, that Ted Lasso does also, right? If you watch Ted Lasso, they talk about your feelings, right? Like, make the feelings an object of discussion and consideration, right? But before Mr. Rogers, and there's a great clip of him reckoning with a senator about this, like, that wasn't something you talked about. And so part of the argument I'm making here is like, let's make teaching and learning something that we talk about, not just in staff rooms, but with our students. We still have lectures on constructivism, right? Like, in a place where students are well versed in teaching and learning, you wouldn't be able to get away with bad teaching, because the students would know, like, well, this is an ineffective pedagogy, right? Like, so I think there's something in there that if we're talking about, that can help to create that dissatisfaction. But if we're not even talking about teaching, or even worse, we're protecting it from view of other people, there's no way it's just like repressing your feelings, right? Like, there's no way we're going to be able to talk about it.
Yeah, that was great. Thank you.
There was a question on this side.
Yes, I mean, I forgot, but I'm going to try to focus on the question. I think you talked about systemic barriers and how to mitigate this. And then, so how do you propose to take care of that aspect, right? Because this is an outcome of your research within the bigger scheme of how to improve science teaching, right? And we know all the push for kind of be STEM, and right, as a way for educating students and focusing on assessments and everything. So I think it might look minute, but in the way I look at it is like, it's, if you understand where they come from and the barriers, then you might be able to engage students better and help them improve their performance, right?
There's that, but I think I'm widening that. That's there. So those issues of systemic barriers, and particularly microaggressions and those types of interactions that, again, from the emotional side, turn people off to science. But I was really inspired by the Black Birder movement on Twitter, where ornithologists, people who study birds, who are not white, were getting harassed in public because people's conceptions of scientists didn't include people like them in natural spaces, right? And so there was this really high push for visibility of, like, Black in science. There's a whole movement, and for whatever reason, it erupted like a volcano after so many things after COVID. It burst to the surface, but it had been an issue. And so part of that is access, part of that is systemic barriers. And the implications for us as teachers is, one, in how we present science and who gets to do science, who gets to be a scientist. There's the whole thing about, like, who are the scientists on our walls and the representation. That's important, but it's not enough, right? We also need different worldviews in the classroom. And I really love Robin Wall Kimmerer's work on, and she's an Indigenous scientist who talks about the scientific method from an Indigenous perspective. Is one of the things that she does. She's a great plant biologist too, but just making room for ways of knowing and avenues for learning. That in a science classroom where somebody thinks of science as, well, we're going to do chapter 1, and then we're going to do chapter 2. Like, that's a very different way of thinking about access to science. But you're absolutely right. It does fall into wicked problem territory, but I see it as a solvable. Part of it is also who our science teachers are. Our science teacher population is extraordinarily white. And at some sense we can ask, like, why? Like, why is it still like that? We've addressed the pay gap, right? When we look at the pay difference, and still there's like a slight difference between men and women. There's different explanations for that, but in teaching, it's very different than on other professions where you do have that 78 cents on the dollar. So, and we've solved that problem. We've solved the pay gap problem with regard to gender in teaching. Can we now solve the who gets to be a teacher problem? And guess what? We solve it the same way with money and resources and attention, right? And I hammer this bell all the time, but free college, we need to stop. University education has to be like K-12 education. And that's one of the ways we're going to solve it. So we know the answers to some of these problems. It's a political goal.
Thank you.
Time for one more question. So
One comment, or do you?
Sure, no, go ahead. Last comment and then we'll close.
I was just thinking, like, we have such a teacher shortage and it's such a crisis right now. Who's going into teaching, retaining teachers? But if everybody, when they're in school, is learning how to learn and how to teach, we could also be identifying teachers, like, wow, you really are great at teaching. And, it could be something positively talked about early with kids. So I'm thinking about that with the outcomes of what you're talking about. But
this is where I give a plug for my colleague Madra Dazal, who is working with the Red Hawks Rising program with the schools where we are doing exactly that. With Eastside University High School, they are taking a public purposes of education course, which is in our undergrad program. That's where they get introduced to some of these ideas of sociocultural learning.
Yeah.
And they're taking that course in high school, and we have them walking down the road to an elementary school, enacting some of these ideas with young children. And so that's a melding of my two different research agendas with the teacher retention piece, because you're absolutely right. Thank you, everybody. This was fun.
Thank you so much. Thank you again. It's just a lot of things to think about, and I think that focusing on teaching and learning in school makes sense. I mean, I think to some extent it's kind of already like the Danielson is monitoring students, helping students monitor their own learning, which I think intersects with this. I know when I was young, we had guidance classes where they taught us how to study, which I think also intersects with that, right? Thinking around that. So I think it's a really fruitful avenue. And thank you for joining us in person. Next week is Thanksgiving, so enjoy your Thanksgiving. We will not be having a lunch and learn. The week after that, we're going to have food and fun and people, and maybe a watch party. Maybe we'll watch some 15 minutes, 17 minutes, something, and talk about it. So it'll be kind of chill and laid back. But we will have something. And then I think after that, it's like December. And who do we have in early December again?
We have Aditi,
Aditi Wag?
Aditi Wag,
Yes, so
and
we have Aditi Wag coming in the beginning of December. So we'll see you all hopefully in 2 weeks. And certainly hopefully after that. But thank you again and have a wonderful week.